So here I'll give a quick overview of how to solve log equations. But before we start, let's just first see what a log equation is. Here are some examples. When do we know that it's a logarithmic equation? So we know it's a logarithmic equation when we have, for example, something like this. It's the log of, and what you see in here is a function of x. So the x, which is the unknown in the equation, has to be sitting inside a log function. So that's when you would say it's a logarithmic equation. Look at the second example. We have log of the unknown. So as long as you have log of a function of x, here we have it again, we can call this a logarithmic equation. Here again, we have log of a function of x. So we need to see an x inside the log function. So we have a log of 3x plus 2. So this is again a logarithmic equation. Look at the last one, log of 5x plus 7. We could have anything outside, but there has to be at least one term with log of a function of x. Now notice here in the second example, I've given you an example of something that's not a log equation. You might see logs in the equation, but it's not a logarithmic equation. So x plus 3 equals log of 7 to the base 5. Look at the log expression or term in this equation. We have log of a number. It's not a function of x. The x is sitting here. This is just a linear equation that can be quickly solved as x. We subtract 3 on both sides to get log of 7 to the base 5. It is a number minus 3. And that's the solution. This is not a logarithmic equation. It is a linear equation. The next one again, notice that when you see the log here, that's log of a number. It's not log of a function of x. This is log of a number. It's not, does not contain x. The x is sitting out here and the exponent on the x is 1. So this is just a linear function that can be solved quite easily. So we have 2x, subtract log 3 on both sides. So we have log of 9 minus log of 3. And then I divide by 2 on both sides and we've solved the equation. So these two equations are linear equations. They're not log equations. For it to qualify as a logarithmic equation, we need to see the unknown, which is your x, inside the log function. So you have to have a log of f of x, log of x minus 7 or something like that. Now, there are two types of log equations. One is when you have log of a function of x is equal to log of another function of x. By the one-to-one property of the logarithmic function, we can kind of get rid of the logs and say that whatever is in parentheses here has to equal whatever is in parentheses on the other side. So basically, I hate to say this, but the log function kind of gets cancelled. We get rid of it, right? But this is the one-to-one property of the logarithmic function. So this is a log equation. We're assuming that the blue highlighted area contains x. Now the other type of log equation is when we have log of a function of x equals to a constant or anything that can be brought down to that form. So here we would use the definition of logs. So we have the blue highlighted function is equal to the base here becomes the base of the exponential term that we're going to write down. So that is whatever you have there is equal to a to the power of b. So you may not see the equation exactly in this form. For example, you may or may not see it exactly in that form. But if you look at an equation and say, I know I can bring it to that form, which is log of something equals log of something, then we can solve it by simply equating these two. So let's look at the set of examples that I have here. Let's look at the first equation here. This is type 2. Look at the second equation. I can bring it to the type 2 form. Okay, because we have a 3 here. I can subtract both sides with log of x minus 7 and bring the 3 to the other side and somehow convert it to the second type. Now this, I can cross multiply and this would turn into the first type of log function or log equation. Now this, I can add 5 on both sides and bring it to the second type of logarithmic equation. So you have to think about exactly which type it falls into. Is it 1 or 2? But you might have to do a little bit of work before you can actually bring it to the form log of something equals log of something else, or log of something, which is a function of x, equals to a constant, in which case we can solve it using the definition of logs.